Hi, my name is Patrick Desjardins, and today we will grow our protocol buffers to have many files and many objects. Creating many objects are preparing the ground for the next video of the series that will mesh the data together with GraphQL. Our current model has only one entity called house. We need to add a new one called person.proto and add a person entity. The entity will have an ID of type integer, a first name of type string, and a last name of type string. Like the previous video, we will use the wrapping type from Google. It means that the file must have the import at the top of the file of the wrapping types. We also need to add two services, one to fetch a single person by one ID or a list of IDs. It's not a requirement to have these exact two services, but it is a good habit to have at least these two endpoints. Concerning the choice of the IDs, while we could handle everything with only a list and providing a single ID, it is more user-friendly to have both and reducing the burden of handling a collection on the consumer side. In the future, other service functions can be added for paging, filtering, etc. We are also using an object for the request and response to give us the flexibility to add future parameters later. Then we will alter the house.proto to have another ID field. We had an integer 32 wrapping type that will be a reference to our person object. We could have the object directly inside the house, but we want to separate the entity because they are two different concepts, and maybe when fetching the house, we do not mind about the person information. We need to be smart about not to provide too much information that might slow down the response or create a response that is bigger in size for the consumer. It might seem inconvenient for the user to query two endpoints to get the house and the person, but this is where the future step that we will create gonna help by introducing GraphQL. The GraphQL server that we will create will leverage the type generation and stitch all the endpoints together without having the consumer to worry about how to get the IDs and which endpoint to invoke. For now, it would still be educationally interesting to get an object without a new endpoint. Hence, let's move the address inside an object name called house address that will be inside the house. Let's move the street name, house number into an object that we name address. So now we have an object inside an object, meaning that anytime we query for a house, we are getting this inner object, the address. At that point, if we are generating the TypeScript, only the house information is generated. The reason is the script that generates TypeScript is pointing to house.proto. To change that behavior, we need to visit the script gen.sh and remove the house.proto for a more generic selector. We will add /star.proto that will get all proto files of the project. We could be less global and specific a single folder where all the proto file resides. We should also generate the files into a folder to avoid polluting our source code generated. Let's create a generated folder and change the gen.sh. And while we are generalizing the code, let's move back to the package.json to change the monitoring script to not watch only the house.proto but any proto file. To do so, we need to erase house.proto for star.proto. So most of the tooling around the proto buffer files are in a good place, and the generation is successful, as we can see in the generated folder. A quick glimpse at the generated file demonstrates the difference between the object person and address. The house underscore pd.d.ts as the house address class, and the house refer to it. The person pbgs as the person namespace with the as object, with the three fields defined in the protobuffer file. One detail is that if we were to reference a message, of any type from outside the proto file, we would need to import it, similarly to how we did when we wanted to have the wrapper types from Google. Now let's modify our fake database in server.ts. To have more data around the new schema we created in the file, we need to adapt the imports, since the generated files are now in the generated folder. We can add two new people in new variable of type person.asObject. We can have an ID number 1 and a name. Then we can reference them into the first house and then add an ID number 2 for the second house, and so on. We also need to move the address from the houses into an object. Because the object is inside the house, there's no need to have a different variable like for person. It's part of the house. We have a great experience with TypeScript here guiding the creation of these objects. In a more realistic scenario, with fetching the information from a database, it can be useful to ensure the compatibility. The next step is to adjust our mapper to have the house mapping properly with the new inner object, but also adding mapping for the person, and also to adjust the import. We will create a mapper for the address and use it inside the house mapper. The idea is the same, and the mapping can be bothersome, as you can see. Nonetheless, it is needed when the gRPC and database are not exactly the same schema. It is also needed because the type is not one-to-one. Finally, the mapping is required but can also be automatized at some extent by having a custom tool that reads the database schema to generate the protobuffer file and then generate the mapping. However, this kind of automation is out of scope for this series. Although we have a big chunk of code generated with our TypeScript that will be generated for us to use in this gRPC project in terms of model entities, but also for performing the gRPC queries and the requests and response types. Lastly, we need to inform the gRPC server that we have the new protobuffer file to know to serve the person endpoint. A visit to server.ts and adding the service to load all proto files. Because we have getID and getIDs, it is quite a simple service to implement. Also, we can see that server.ts start already to get crowded with only two services, the house and person. Hence, we should refactor the code to have a service folder and having one file per service, and at the same time a folder database with our fake database. We also need to add mapping for the person entity from the database format into the gRPC format. The mapper will have two new functions, one for a single person and one for a list of people, similarly to the house and the houses. An alteration is needed for the house mapping. We need to map the owner ID. If we forget about it, the response will contain a null value. At that point, we have the proto file altered from the previous episode, the mapper and the fake database. The generation of TypeScript and JavaScript are successful. We can try out with the Bloom RPC client, the house and the person. First, let's query for house number 1, number 2, and number 3 and see the payload. We can see the address being imbricated inside the house and the single owner. This is working for each house. Now let's query for the owner and we can get the data. In this episode of the series of automating types from backend to frontend, we have reached the step where we have many entities, houses, and people. We have modified the script that generates TypeScript to handle many protocol buffers, and we have worked with two types of object. An inner object that is the address and person that is outside. In the next episode, we will create the GraphQL server that will leverage the automation of the gRPC client and the two gRPC services. See you soon.